Go ahead and get started. Thanks everybody for joining me this afternoon. I know we've had 2 days of great talks and it can feel like a lot in your brain. I've definitely learned a lot over the past 2 days. So thanks for spending some time with me. And today I'm going to be talking about why great models fail, lessons that I've personally learned from 9 years of working in the machine learning space. One thing I've definitely learned is that not every single model that you build is going to be destined for production, make it into production, or have that longevity in production. And that's sometimes even the case when it's successful in your development environment, when you're creating that proof of concept model. So I'm going to be sharing some of the mistakes I've personally learned and what's a good strategy that you all can walk away with to set your models up for success all the way from the beginning of that project stage, that ideation, to the end of development and launching it into production. First, a brief introduction if I haven't already met you these past 2 days. My name's Robertson. I'm the chief machine learning engineer at my own consulting company. It's cool when you own the company, you get to call yourself whatever you want. So I'm a chief today, and my company specializes in consulting in the machine learning, data science, and AI space. I've helped companies of lots of different sizes, anywhere from under 40 people to over 40,000 people. And my goal is to really help empower teams to use data to do their jobs better. So building projects that are directly tied to stakeholder and business strategy. And I really pride myself on being the intersection between technical and non-technical teams. My background, all my degrees are math and statistics. So working with teams who maybe don't have those technical strengths that I do and helping them implement data-driven solutions that help them while understanding their limitations, understanding that best solution given whatever time or budgetary restrictions that they have. So I wanted to open my talk to encourage the audience to reframe a little bit about how we view success and failures. I put failures here in quotes because I want to encourage you to think about them as a learning opportunity. Lots of people come to conferences and they talk about their successes. Here's a model I built, here's a package I built, here's this new area I'm researching and discovering. And that's important and that's great, and you should be proud about those accomplishments and talk about them. But I want you to think about failures are also very important, especially when you're working in industry and applying technical things. You can learn a lot from the things that don't work. In machine learning, if I'm starting out with a new project, I'm probably fitting 5+ models and running experiments to see what works best. Those models that didn't work aren't a negative. That informed me about how I needed to maybe make changes. It's making me more efficient. I've learned a ton from things that haven't worked well. And I'm particularly a very hard person on myself, but I've tried to reframe how I think about this as well and acknowledge I wouldn't be the engineer that I am today if I hadn't made some of these mistakes along the way, because I've learned from them, I've grown from them. So a question for the audience: how many people here have built a great product and maybe they've not seen it adopted at their company? It's okay, you can raise it high. I just said failures are a learning opportunity, so we learn from it, right? I have too. How do I know about failures? I'm gonna talk about one. I've decided to fly all the way to a different country and tell you about something that I did wrong. Kind of a weird vibe for a conference, but let's roll with it. And I'm gonna start off with this motivating example. I'm not gonna go into the nitty-gritty details of the project just to protect the IP of the client and the project. So some details are gonna be a bit vague on purpose, but hopefully we'll hammer this idea home. So this is a social media analysis project that I was building for a company where this company, it was really important for them to be ahead of the trends in their space. Wanted to be on the cutting edge because it was important to them to distinguish themselves from their competitors with innovation. And I knew there was a stakeholder team who they spent a lot of time monitoring social media sites and content creators with the hopes of catching trends or hot topics before they became a bit more mainstream, looked at the target customers, and these were customers that were known to be high value to the company and that they were really passionate about the products, talked about it a lot online, a really core group of consumers. And I had the idea of, I know a lot about NLP. I had just taken a course on it, and I wanted to flex some of those language modeling muscles, and this seems like a great opportunity for it. Can show off my skills while also helping a stakeholder, with the goal of being able to answer that second question, what are the trending topics of conversations? So I could take my NLP skills, some text data, and be able to tell the stakeholder team, here's what these high-value customers are talking about, without them having to sit through and reading some of those social media posts. Very high level of what I built, and this was all to create that proof of concept model. I had an archive of text data from a popular social media site that these high-value groups of consumers were known to talk about, messaging boards about products of interest, events, about this company, about their competitors. So if you work in data science or machine learning, you're probably excited about a vast amount of text data. I know that's not everyone's cup of tea. And from that text data, I was able to build different language models on that. So in particular, I built what are called topic models. If you're not familiar, what a topic model does is it looks at documents. In this case, a document would be a social media post. And for each document, it will translate the words that are in that document to numbers. And then it looks at what words are occurring together, what's the ordering of it. And from there, you can get a topic summary out of a bit more nuanced than maybe if someone's going through and reading it. And I was able to evaluate it on a score called topic coherence. And that's just a way to measure how well a particular topic is supported by a document. So if I have social media post A and it's in topic 1, I can mathematically define how much that post is relevant to that assigned topic. Not an NLP talk, so if you want more resources on that, let me know. But the gist of it was I had a model that was performing well by an industry standard, a quantifiable metric. And from there, I was able to produce a trending topic summary. So from all of that social media data, I could then say, here are some topics that your high-value customers are talking about. Here's the language that they're using in them, any keywords. And to me, this seemed like kind of a home run. I got to practice my NLP skills, and I saw this as being a very high-value add for that stakeholder team. But remember, I said we're going to talk about failures a bit today. So there were a few shortcomings with this project, and I'll say this was one I did a bit earlier in my career and has definitely shaped the way I approach working with stakeholders and clients today. Number one was minimal stakeholder consultation. So in my previous slide, I talked about what models I used, how excited I was. I didn't mention at all actually talking to the team that I envisioned using this model, which ended up being pretty bad because this didn't end up being as much of a value add that made sense for them. They had some other higher priority needs from a technical perspective that it didn't make sense to invest the time and money to scale something like this when they had other bigger problems they needed solving that would have more of an impact at that time. And also, it's the second point, the cost of the data. And part of this is related to not talking to my stakeholders. I had the great fortune at the time of I used an archive of social media data, and about a month before I was working on this particular social media site decided they would change how they would charge for their data through their API. And it went from, for this company, being a drop in the bucket to, oh, that's a pretty big line item for next quarter. And I think part of that is we're seeing an AI boom. These companies are recognizing the value of their data, especially around text and languaging, or in language. So for me, I thought this was this great thing, and then I started figuring out what's the cost of actually scaling it into production. And if I had talked to the stakeholders, we could have maybe had a conversation around some of it's coming out of your budget, some of it's coming out of mine. But because I hadn't talked to them at all, and this project wasn't adding the value that I thought it was, this model ended up in what I would call model purgatory with scary looking Elmo. So sadly, this project, while it was performing well by that quantitative topic coherence measure I mentioned, I don't think the code has ever made it outside of that Databricks environment where I did all of my model testing looking at the proof of concept. The Confluence summary is probably somewhere in the ether of that company. Maybe an ambitious new hire has uncovered it, but my point is I built what was mathematically a solid model, but at the end of the day, that high performance wasn't enough for it to be put into production, scaled in production, have something that stakeholders and end users were regularly using. And a lot of machine learning models and projects can end up here, and there's a couple different reasons for that, which I'll use to transition to the next part of my talk. Let's understand what are some of the reasons why we're seeing these great models fail. I've only got an hour today, so I'm going to talk about these two kind of bigger ideas because in my career of almost a decade, these are the two big patterns that I've noticed or experienced why you could have a model that's good in your proof of concept, your testing environment, not have that success in industry that you envisioned. So number one, the scope of the work is not fully defined. Part of my shortcomings with that social media project was I didn't even talk to the stakeholder. I thought I knew what they needed. I was excited about using this technology and kind of, I don't want to say forced it on them because they didn't adopt it, but there was disconnects on what was actually needed to solve this problem and what I was building. And the second is the world changes over time, which you might be like, duh, Megan, the 30 seconds ago is not what it is now, which I agree with. But remember, when we're training machine learning models, you are training it on a subset of data. That data represents one point in time. So my machine learning model understands the relationship between my input variables going into a model and what I'm predicting with it, and the math is what defines that relationship. That relationship is going to change over time, so if I'm using math I fit 2 weeks ago, that could already be outdated. So today I'm going to talk through what does it look like to scope out a project properly, as much as I can in an hour, and then second, what are some of the ways we can think about setting up our models, especially in a production environment? So as the world changes over time, we can be alerted to when our model performance is starting to change because of that. And what are some of the strategies that you can use to update that model to fix those changes? Okay, if it wasn't already clear from my previous slide, I wanted to put it in capital letters to really make it seem important, because it is. Proper scope is the foundation of a successful machine learning project. I get it when you're starting a new project and there's all these different data sources and all these different models that you can try. That's my favorite part of it. And sometimes you have all these ideas and you just want to jump in right away, start making graphs, start doing math. But if you do that, it can be easy to kind of go down a rabbit hole a bit and maybe not actually be solving the problem that you need. And you don't want to show up with your V1 deliverable and be like, look at this great model. This is what I did in my social media example. And the stakeholders kind of sitting there, kind of maybe looking a little confused, not saying anything because what they thought you were going to build is drastically different than what you showed up with. If you're properly scoping a project, you can really make sure you're on the same page. And especially at bigger companies, there could be a lot of different teams that have to work together. So properly scoping means that everyone's going to know what goals they're working towards. It'll help save time, money, and frustration throughout this whole model building process. So what does it mean to scope a project? This is a very high-level flow chart of what that looks like. You could argue there are more steps in there as well, depending on the complexity of the project, but we're only here for an hour, so I wanted to keep it a bit more high level. So you can imagine stakeholder request comes in, or sometimes I've been on machine learning teams where we can pitch our own ideas from understanding the business. So these are the two different asks you could have come in. Your first step is going to be to define the project. And you might be like, well, duh, Megan, we have to know what we're working on. And that's great. But in define the project, I mean, really getting into those details of who are you serving? What is the project you're trying to solve? And what does success look like in that project? From there, you need to understand the constraints and risks. I wish machine learning happened in a vacuum. Compute's a lot more affordable than it was a decade ago when I started my career. But the fact is that the cloud, while you can't see it, still costs a lot of money depending on the size of your data. You have timelines to deal with, what other projects you're already working on. And then the risks, you have to understand what can go wrong if my model goes wrong. Next, this is personally my favorite step, is to identify possible solutions. So knowing what I need to get done and what success looks like from that first step, and given the constraints I have, what are some of the things I can build to solve that problem? So for me, this stage is often fitting a few different machine learning models, maybe doing some A/B testing, looking to see what's my most promising solution. And then lastly, plan maintenance and monitoring. So I've got a star on that because this is part of scope, but this is also where, more towards the end of the presentation, I'll talk about what are some of the things we can do when the world changes and we see our model performance degrading as a result. There are ways that we can catch those changes, implement those changes, and make sure it's done before maybe a small problem becomes a big problem. That's more of like the infrastructure side of things. And I put at the bottom here this question in the dotted box of what is your value add? Because at the end of the day, you need to be building stuff that's serving the business and the stakeholders. So through each step, I always like to take this as kind of a grounding question of, is what I'm defining in each step contributing to a business goal? Because I've done it where I see a project, I'm really excited to apply a new technology, and I kind of run with it. And every day it gets further and further away from what's actually needed. So kind of coming back to this question can make sure that you stay on track. So now we're going to go through the different steps of this project scope to understand what's the sort of information we need to be getting at each step. And then I'll also talk about what are some of the trends and mistakes or missed opportunities I see in each of these steps. So first, we need to figure out who are our stakeholders and end users, identify the problem that we're trying to solve, and then also making sure that we are defining success, and success in a quantitative, measurable way. That's very important. All right, so we're going to identify our stakeholders and end users. This might seem simple, especially if you've been at your company a while. You're probably familiar with who your major players and stakeholders are. But as somebody who's especially worked at companies that can be tens of thousands of employees, it can be easy to overlook stakeholders just by not knowing the different areas of the business. So we want to understand who is going to be acting on my predictions from the model. Let's say that I'm building a model to predict whether a customer will convert from an email sale. So convert means I've clicked into the email, I go to the website, and I make a purchase. What are some teams that we think might be interested in a model like that? Sorry, I'm forcing you to participate on a Friday afternoon. For a marketing campaign, maybe the marketing team. So kind of really thinking through that, a sales team might be interested in it. Who owns the decisions that are informed by the model? This could be very similar between the first and second, but that'll also help me understand, are there more senior people that I really need to loop in? And what workflows does this model touch or affect? So I've built models that will serve predictions and summaries into a dashboard. Who's using that dashboard? Or sends out an automated report. What email list is that going to? Or maybe you're serving an external API that's creating some experience in a phone application, so it's being customer facing. So really taking the time to think through who I'm going to be helping, because understanding their roles and goals at your company is going to help you be more informed in building them the best solution. Next, we're going to identify the problem to solve, which seems maybe like another no duh, I get paid to solve problems. But here, it's about getting a bit more defined in what you actually need to be solving. And when the request comes in, it sometimes can come from your stakeholders or it might be a team idea. I would like to give the call out of, if you're working with more non-technical stakeholders, especially if it's a team you haven't worked with before, oftentimes there's a difference between what the stakeholder thinks they need and what they actually need. I had a VP who loved to go into meetings and would literally say, oh, what's your problem? The data science magic will solve it. And would come back to us and say, hey, so I promised this in 4 weeks. And we'd all sit there and look at each other like, so that is an interesting opportunity. And sometimes too, especially, I don't know, has anyone heard of a thing called AI? Kind of a buzzword right now. Like, stakeholders will come and use the buzzwords because it's what they think they need, but they might not actually have a pipeline of clean data, which isn't super helpful if you're trying to build an internal chatbot, for example. So really asking these questions so you can figure out what they actually need. And if your team is trying to come up with ideas of what a stakeholder might use, these last two questions I like a lot. What do you wish you knew about your customer or whatever group of interests that team works with? And are there any manual or semi-manual tasks that take up a lot of your time? That's what I was trying to solve with my social media analysis. But by talking to the stakeholder and getting their input, you'll also know what projects are high priority for them. Because at the end of the day, you want to be working on those visible, high value projects. And these are the questions that are going to help you identify those opportunities. The last part of this first stage of project scope, we want to define success. I'm a math person. It is very, very, very important that you quantify this, which you're like, machine learning, statistics, no duh. But I have seen projects where they're like, yeah, the model's doing better. I saw 3 tweets yesterday talking about this campaign we did and they were all positive. Like, okay, so that's promising, but also that's probably how your algorithm is serving you. And defining success, especially if you're working with non-technical stakeholders, can start out a little vague. That's fine. Not everyone you work with is going to have that language to transform something into a quantitative KPI or key performance index. So here we have some examples of just what are some common KPIs for these types of situations. We want better marketing campaigns. That's great. That sounds good for the company's bottom line. But what does that actually look like quantitatively? So we can look at things like unsubscribe rate, bounce rate, conversion rate. I send a marketing email. How many people leave my mailing list because of that marketing email? How many emails don't exist and it bounces back? Conversion rate, again, that's how many people are actually going to a sale. These are ways that I can quantitatively talk about that value out of my model. We need to keep users engaged in the app. Daily active users. How many people am I seeing every day? Is that number changing? My churn rate, how many people are still using the app who signed up a month ago, a week ago? Or our last vague situation, we need more users to like our content. And that can look like click-through rate, how many people are clicking into that piece of content, or time on page, how many people are just clicking in and leaving right away versus going into that content, scrolling all the way through and reading it. And this step is super important, and I'm gonna sound like a broken record by the end of this, because the biggest part of building machine learning models in industry is the value add of your model, which is gonna be defined by these quantitative measures, is greater than any cost or risk that come with it, which I'll talk about a little bit later. So what are two of the big mistakes I see that tell me you didn't properly define the project in your scope? Number one, I've done this, I'll raise my hand, maybe not so proudly, but I've learned from it. Building what is cool to you. I think this temptation is even greater now than it was 10 years ago, because I'm sure people have heard AI is taking all of our jobs. The robots are going to do everything by, I think, next year, according to Altman at this point. And I'll feel the pressure to try to keep up with technology as it changes. And I can sometimes want to build that cooler, newer technology model, but it's like trying to take a round peg into a square hole of I'm trying to force a solution when it doesn't make the most sense. So in this, what we might see, there's not a stakeholder who wants to use what you're building, even if it's really cool and the predictive power of your model is high. And the contribution of that model isn't going to outweigh the cost to maintain it. So the value add is less than my cost. That's basic math. The business doesn't like that. Next, evaluating on vibes. I'm talking about vibes without saying coding after. I'd like to point that out at a dev conference. And this, I've seen that example where, oh, I saw three positive things in the wild about this new product. It must be doing well. You need to be able to quantify the contributions of your model, because if I can't quantify the contributions, I cannot justify the cost of its maintenance. So these are two big things to just keep in mind when you're scoping a project in that first stage. Next, I want to make sure I understand what are my constraints and risks. Two big areas with that: identifying available budget and bandwidth, and then also making sure I think through what are the effects of bad predictions or recommendations. And machine learning doesn't happen in a vacuum in industry. You really need to understand realistically what constraints you're operating under, as well as potential negative effects. Because if you're a person who's building machine learning models that are being used to make predictions in the world, affecting people day to day, as the developer, I would argue that we have an ethical responsibility to understand what are the effects of these tools that we're building, how can it cause harm. There's a lot with machine learning and AI that can improve people's lives, but we also need to understand the risks that accompany these technologies. Some of the questions that I'll make sure I have the answers to identify that budget and bandwidth. What is the expected compute power needed? So I presented the project scope as kind of a 1, 2, 3, 4 step. In reality, some of these steps are going to overlap. So in the next section, I'll talk about how we brainstorm solutions, which, if I'm going to build a logistic regression model versus a neural network, those are two very different compute powers. So this first question, you'll have to kind of think about that next step as well with it. And also knowing, is there a cost to acquire any additional data? I really wish I had asked that question before I spent 3 weeks building language models, because especially today, data is a highly valuable resource and companies will pay a lot of money for it. How long will it take to build the model? I'm usually trying a few different ones. So we're thinking about, what do I think will work? Having time to do any A/B testing to compare performances of different models against one another. And what are my team's other priorities, and how does this project compare? So I'd say a lot of these questions some of it just comes with experience. Like if you had asked me 10 years ago to answer these on some of them, I don't know. The neural network takes a long time and I'd be a bit more unsure about some of that stuff. So some of this just comes with experience. And then with the other priorities, it might be a case where a project comes up that's really high priority and you have to now adjust and shuffle around other things. But if this is the bottom of the list and my team doesn't have any time, that's telling me something about is something that I don't necessarily need to tackle right now. It might get pushed to next quarter. Also in this stage, I need to brainstorm bad outcomes. I'll be the first to admit I'm a glass half empty person, but I'm not just saying this to kind of be a Debbie Downer. It's important that you understand what are the potential risks of your model. Because I could have a model that performs really well, and it might not make mistakes that often, but if the consequences of that mistake are catastrophic, that's probably not something I should be putting into production. So questions we want to think through here: what population is harmed by a bad prediction? Is it just my stakeholders lose money, the company loses money, or is this something that is customer facing, has an effect on people's lives? I like to think through, when is it okay for the model to be wrong? If you worked in machine learning a while, you'll know no model is right 100% of the time, but there are certain situations where it's a lot worse for it to be wrong. So if you've taken an intro stat course, you might remember the conversation around type 1 versus type 2 errors. So let's say that I have a model that is predicting, it returns a probability that you have cancer. I don't know, I don't touch medical data because of HIPAA. It makes my business insurance very expensive. So this is all hypothetical. But let's say that I have actually a very low probability of having cancer, but the model tells me I have a high probability it's wrong. And this means my doctor says, go do all these expensive tests. And eventually I find out I don't have cancer. The other way it can be wrong is the model says you have a very low risk, but I actually have a high risk. And now my doctor says, let's not spend money on the treatment. I'm from the States, that shit's expensive, and we're not going to put you through all of this. And now I'm very high risk for this bad disease, but I don't know it. Is there one of those options the people in this room would prefer? Probably. Okay, I'm going to imagine you're all nodding. Thank you. So here is a situation where, kind of thinking through this last question, what are the risks of an incorrect prediction? There are times with machine learning models where it could be life or death, especially if you're in that healthcare space. It could be monetary. We're losing a bunch of money. So this isn't to be all doom and gloom about machines and where they can go wrong, but the reality is that value out of our model, there it is again, needs to be higher than my costs, as well as I need to make sure that the probability of a catastrophic outcome and that consequences aren't so big that it is greater than that value add. Some common pitfalls here. Number one, ignoring budget and bandwidth. I did that. And in this case, the cost of the best performing model could exist, what those computing resources are. Oftentimes, a more advanced model could perform better than a simpler one, but that more advanced model is more time to fit. It's more complicated to understand how it works. It can take longer. And the team doesn't have the capacity to scale that into production. So even if that more complicated model performs well, it just doesn't make sense given the constraints. And next is underestimating risks. So in the cancer situation, even if my model does really, really well, a small mistake could cause really big harm to the end user of that, and the risk might not be worth the model payoff. So really making sure that you're thinking through that, because if my model performs well from a predictive standpoint, but a mistake, even if it's low probability, is catastrophic, that's not something that's going to necessarily serve the business well. All right, so next, we want to make sure, identify possible solutions. For me, this is the most fun part, because here's where I kind of get to flex my statistics, my math, all of that stuff. Two big steps here. We want to understand existing capabilities and solutions. It's really cool if you're working on something novel, but oftentimes someone out there has tried to do what you've done before, and it's helpful to learn from them. And this is the stage we also want to get clear on what that minimum viable product is, or the MVP. So looking at understanding existing capabilities, here are a list of questions. Has somebody tried to solve this problem before? And that could be internally at your company, so searching internal documentation is good, asking around. But this could also be coming to conferences, seeing what sort of problems are being solved. For example, if you're trying to build, if you're on your search team and trying to figure out how to return products on your website based on a search, a lot of people have done that problem before. Look for white paper, see how you can adapt it. Make sure you're understanding what you can learn from previous attempts, even if those attempts maybe didn't end up going into production. As I said, failures, we can learn from them. They're learning opportunities. So you can use that to be more efficient, try something a little different, understand where they went wrong. And then lastly, is there an existing tool that you can adapt? So maybe your model predictions are going into a dashboard, and somebody already has a whole model pipeline that uses all the same data, and you're just adding a new prediction. If you can adapt those tools, that's going to save you time, and that means that that model value add is going to be higher than the cost. Now, this personally is my favorite part, because here's where you get to start kind of brainstorming about solutions. What are the different models out there? For our MVP, we want to understand what is the most basic solution. And here you can see I have a photo of a baby circled, because I like to think about this ideation process as a crawl, walk, run approach. Your MVP, you are crawling. You are doing the minimum that solves that problem you defined in the first step of your project scope. And you're really thinking about what would convince the stakeholders this is working. We have those quantitative measures of success we defined. What does a stakeholder need to be or need to see to agree that, oh, this is something that's working? And then lastly, how will that output be consumed? Could it be a dashboard? I know dashboards have, the dashboard has been dying for 5 years apparently, but it is still a really powerful tool for getting people access to the products you're building. It could be a summary report. You could be serving an output to an API for other teams to consume. So at this stage, you want to understand what is it exactly we're going to try building. And I emphasize that crawl, walk, run approach, because it can be really easy to get excited about, okay, we have a model to predict this. Oh, but what if we include this data and this feature in the dashboard? As you add more things that can break. And the goal of the MVP is to show this model has value to the business. And that walk stage, that run stage is where you can get a bit more advanced. But if I have too much complexity at this stage, I'm introducing that risk of something breaking. And if that breaks, my model that performs really well might be obfuscated by that. So our common pitfalls I see at this stage: reinventing the wheel. You didn't look to see what had already been done. And maybe you build a model that in your proof of concept performs really well, but turns out someone's already solved the problem and their model does a little bit better than yours. So now you've wasted resources and time, and you haven't provided any value above projects that already exist. The second step I kind of harped on already, because this is just something I see a lot in industry, is delivering an overcomplicated solution. So it could be the case of, let's say I'm predicting sales, and I'll build a very simple linear regression model. If you didn't take intro stats, that's the model where it's a straight line, and you hope most of the data points are around that straight line. That's kind of one of the most basic models you can fit. A very complex solution would be what's called a neural network. That's the basis of what's powering a lot of these Gen AI language models. And if my super fancy, sounds cool model only performs 2% better than my simple model that will take me less than half a day to productionalize and build a pipeline, oftentimes businesses go for that more simple model. So just things to keep in mind: those more complicated solutions take a lot of resources to launch to production. So you're introducing more cost, and you can also introduce more risk, because when they go wrong or perform poorly, it can be difficult to kind of tease out why. They're just not as interpretable as simpler solutions. All right, we're in the home stretch now. Thanks for hanging with me. our last section to talk about is this maintenance and monitoring. And this is where we're still covering project scope, but it also transitions a little bit into how are we accounting for that second reason why great models fail? The world is changing, our model performance is changing. And for this step, we need to make sure we know where the pipeline can fail. And when we know where those failures can happen, make sure that we're planning a robust monitoring system, because if it fails and I don't know, how am I going to be able to fix it? I built a pipeline like that where there was an error in the overwrite to the table, and instead of throwing an error saying, hey, I didn't update, it just ran and stayed silent. And 2 weeks later found out because someone said, hey, you know, this data hasn't changed at all. So very important, learned about monitoring systems that day. And then also having a strategy for fixing those failures, because if model pipelines are going to break, shit happens. But you want to make sure that you can catch those breaks and fix them before it becomes an issue that your customers have to deal with, that your CEO notices. So preparation here is really key. All right, this is a very simple summary of what a production pipeline can look like. I'm sure there are steps in here that you could argue could be added, but for the sake of being here for an hour, this is what we're going to talk about. And my data ingestion, that means I'm bringing in data from different sources. That could be internal tables I'm joining. It could be calling an external API from a vendor, getting all of the data I need in its raw format. Feature generation, I'm taking all of that data and I am summarizing it into a form that I can use in that model. So for example, if I am predicting something at the customer level, I don't want to put their raw address into a model because of the amount of different addresses there are in the world. So I might be summarizing by state, by zip code. That's what I mean by generating features. It goes into my model for training. This is where the model takes that input data, looks at the output, mathematically defines the relationship between the two. And this is a step that doesn't often occur in the pipeline. I'll argue that it should a lot, but that's a discussion for another day on a whole talk about production pipelines. That model I'll then use to make predictions or inference. So predicting what you're going to buy, what our sales are for next quarter. And then lastly, the serving stage where it's going to a dashboard or it's going to an API, wherever my results are being served. And below I have examples. These are just examples of things that can go wrong at each stage. Some of them overlap between stages. There's a lot more than this, but just wanted to provide a few examples. So I tend to work more in the 1 through 4, so I'm just more familiar with things that can go wrong in the data, but a pipeline can break. Your vendor changes the schema, so the format your data comes through and they just don't think to tell you. All of a sudden, every customer appears 5 times instead of 1. Jobs can get delayed. On the feature generation side, we can have what's called feature drift, where the actual distribution of my data changes over time. Drift will be a focus of the last little bit of the talk, so I won't go into too many details there. In my model training, I can overfit. That means that my model learns the relationship of the data used to fit it too well, and it doesn't generalize well to other data sets. I could have model drift. The world has changed. My model doesn't know that relationship in the new world as well. It doesn't perform as well. I could have my model file be corrupted and now it doesn't load. And in the serving space, maybe my data size balloons overnight, the company grows. Now I'm going super slow because I don't have enough compute or there are latency issues. I update my dashboard instead of refreshing in 2 seconds, it's now taking a minute or timing out. And notice the annoying one at the bottom, dependency failure. Something fails in stage 1. That's going to oftentimes carry all the way through to the end. Has anyone seen any of these failure points in their own work? Yeah. So once we know where the model can fail, it's important to have a robust monitoring system that's going to tell me, hey, this model has failed, danger zone, and either can send me a Slack message, can send me an email, alert the engineer on call that something has happened. And there's a ton of companies who they just do, or products that just do monitoring systems. There's open source solutions. So this is a pretty big area of this process because I want to be able to catch the error before it snowballs into something bigger. So examples of things that I would monitor in a system to catch some of the issues I talked about on the previous slide. First, data issues. And it can be really basic stuff as well. I'm going to be looking at summary metrics. Okay, the average age, is it all of a sudden going from, 24 to over 100? That's telling me there's probably an issue with some of my tables that are coming in. For distribution changes, a couple examples of statistical tests you can use are the chi-square and Kolmogorov-Smirnov test. So what those do, it looks at the distribution of my data, bell curve. They're not all shaped like bells, but it's plotting all the values of that variable. It can look at what did they look like last week? What do they look like today? Are they so mathematically different that I think that underlying distribution has changed? If it has, great, send me an alert so I can look in to see, is it a data issue or is my data, are my customers just starting to change? I also like to see how many missing values come through. If all of a sudden 80% of the table is missing columns, that's probably a red flag that I want to look into. For model issues, a lot of this will focus on whatever quantitative way I am looking at the performance of my model. So things like mean absolute error or mean squared error, that's if I'm predicting a value, those metrics tend to come in handy. If I'm doing a classification, predicting a 0 or a 1, precision, recall F1 scores, those are all different ways to quantify the performance of a classification model. And I threw in one for language modeling because they're all the rage right now, semantic similarity, where that's looking at the degree of similarity between the different words that are occurring in sentences. So for my model issues, I'm tracking these every week or every time this pipeline runs and monitoring, saying if there's a change of X size, you need to tell me about it so I can start to investigate why that's happening. And then lastly, the infrastructure stage, some things I would monitor there is looking at timeout rate. Is a step of my pipeline now timing out and have to be restarted a bunch? Looking at my latency summary, how long are things taking to be served? Or comparing it to my service level agreement. So what did I tell the stakeholder or the client how this was going to work in terms of serving in latency and what's actually happening? So those common pitfalls in this stage, the one which I've done myself early in my career is a lack of adequate monitoring. And this is bad because you're unable to catch any error before it grows into a bigger problem. That was me. It said it was overwriting the table that this very visible solution was, and I didn't know until a stakeholder told me 2 weeks later. So that meant for those 2 weeks, something wasn't working in production as it should have been. And if this happens enough, you can lose stakeholder or customer trust in your team and model. Also, it can snowball into a really big visible issue that could harm the company's bottom line, the reputation of your team. The next pitfall is ignoring model drift. And I'm going to use this to transition into the last few slides where this is where we're talking about the world has changed. And my model, which was performing well as my proof of concept, now the world has changed and it just doesn't capture the new relationship in the world. So data is changing over time, and it's common for machine learning models to be used to intervene. What do I mean by that? If a lot of my experiences with retail companies, this is why I talk about customers a lot, but if I'm using a model to identify this customer is really likely to make a purchase, let me send them an extra nudge. I'm intervening in their behavior now. So you might see your model changing because you're using the predictions to try to change what's happening in the world. And your model performance isn't great anymore. So this last little bit, we're going to talk about model drift specifically. This is going to be a bit high level as well. I've done a whole talk on model drift. I think it's a really interesting area. But I wanted to include this quote from Ben Wilson's book, Machine Learning, Engineering, and Action. A quick plug, if you're an MLE in industry and you want a great resource on how to take a project from ideation to production, experimenting on models, working with stakeholders, there's a lot of great information in this book about it. But in his book, Ben writes, models will drift. There is no such thing as static implementation. And I think about this quote when I'm building my own production systems. It's something to keep in mind because it really drives home and emphasizes the importance of that monitoring. You could have the best model and put it into production, it's working great, but the world is going to change over time. And depending on your use case, it could be in 3 months, it could be in a year. Different industries are different. And you need to have a plan in place to make sure you catch that drift and you're updating this production model. Why do models drift? I've said probably 50 times today the world changes, but the world can change in a few different ways. So understanding what's causing that model drift will help you pick a strategy to fix it later on. So the first one is concept drift, and that's where we're seeing a change in between my input and target variables. So between the variables going into my model and what I'm predicting. An example of this, you'll see it a lot in a situation like credit card fraud. I'm trying to classify, this weird charge came through on my customer's card. Is it fraudulent or not? Should I let it through or should I text them and be like, hey, is this you? And that's because as companies get more advanced in fraud detection, the people who are trying to steal your credit card eventually learn ways around those patterns. So 3 years ago, what was maybe very indicative of fraud is probably different than what is today because they've adapted in those 3 years to be more successful and keep stealing information. We have data drift. That's a change in underlying distributions of features. You'll see this a lot with seasonal products. So if I have a bunch of data on customers and I sell pools, my data is going to look a lot different in January than it does in July. Label drift is another one. That's where that target variable distribution, what my model is trying to predict, changes over time. An example of this would be I'm a phone application and I see a 5% churn every month of users who don't come back. This month, a new competitor launches and they do a lot of marketing, and all of a sudden my churn is 30% because they've stolen a bunch of my customers. That would be an example of label drift, a change in what I'm predicting. And then lastly, I'm a millennial, so I have to put a meme in a conference talk, reality drift. And this I kind of think of oh wow, things have rapidly changed and the world is just so different right now. You can think about customer data in January of 2020 versus customer data in March of 2020. If I'm a brick and mortar store, things have changed rapidly, and that's more an effect of, I guess you could argue, we could have seen COVID coming, hindsight's 2020, but something so drastically changed, so big that I don't have that signal in the data and things are just completely different now. All right, my model is drifting. What can we do about it? Recognizing from that previous slide what type of drift you might be seeing can help you pick a solution. So first is I can look at redoing my feature engineering. If I have data drift where my input variables now have a different distribution, I might just need to change how I summarize them. You'll often see in machine learning, people will apply the log function to a variable to make it between 0 and 1. That's an example of how I could change some of those input features. I might need to retrain my model. So I personally like to, in a production environment, have this built into the pipeline. But if you don't have that, another option is would be to retrain that model, because my model understood the world 6 months ago based on that subset of data that I fed it. And now I need my data or my model to be more recent, have more up-to-date data, and that's all it's going to take. A third option is we need a completely new algorithm. So remember that a machine learning model mathematically defines the relationship between my input features and what I'm predicting. If the world has changed enough, that could be a completely different structure of a mathematical relationship that my model just can't capture. And if you spend a lot of time in machine learning, you know there are some models, for example, that do really well when it's a nested, kind of like a tree structure of what you're trying to predict, versus something that's more of that straight line linear. So that might just be the case of that relationship has changed. I have to try a new machine learning model, even if my model performed really well in that dev environment. And then lastly, I know I promised strategies to help our model stay in production, but I'd be doing the audience a disservice if I did not mention this. You might just have to retire the model. Not every machine learning model you built is going to be destined for greatness and forever be in production. Sometimes you just need a solution for a year or 2 years and it gets the job done, and company priorities, stakeholder use cases can shift, and you have to avoid the sunk cost fallacy a little with this and just acknowledge it's did its job, it's time to move on to a new solution. All right, so I just want to wrap up with a few key takeaways where if you don't remember anything else from the past hour, please remember this. Number one, I really hope this is clear. A highly predictive model is not enough to succeed in industry. We need to make sure that it's serving a stakeholder need. The value out of that model is higher than that cost in time and compute, and also higher than the consequences of if something goes wrong with it. Stakeholders should play a key role in project scope. So they're the ones who are going to help you figure out what is the problem I'm trying to solve. They also have great subject matter expertise that could help you. I've definitely talked to stakeholders and how they describe problems. It's really just opened my eyes on what sort of models would make sense for that case. So really value the expertise they bring to the table. I'm not saying it's anyone in this room, but I think sometimes, devs and engineers can be a bit, well, I'm a technical person, I don't need to talk to anybody else, but this is a key relationship for me if you're working in industry to make these models successful. And then lastly, I'll say it one more time, just to really drive it home, is a model represents a single point in time, and the world is changing over time. So you need to be prepared. Machine learning is not set it and forget it. You really need to think about that monitoring system, that strategy to capture those changes and make sure that your model still performs well over time. And with that, this QR code will take you to my LinkedIn, and my email's up here as well as my company website. I'd say if you have questions after the fact, LinkedIn, email are the best ways to get in contact with me. And I'm also happy to answer any questions now, or feel free to come up to me after. And thanks for spending the afternoon with me.